Okay, so in this video we will try to show that 1 plus 1 half plus 1/3 plus dot 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 plus 1 over n time 1 plus 2 by 3 plus up to n greater than or equal n square. Um, we will solve the problem by mathematical induction. So starting from the first n, uh, um, taking n equal 1, and then we want to find out whether this inequality holds at 1 equal n or not. So when n equal 1, the first summation, the first sum, there is only one term, because when n equal 1 we got 1 over 1, and 1 over 1 is 1, so there is only one term, this one, for the first parenthesis. So in the first parenthesis, when n equal 1, and then I get number 1 because there is only one term only. And in the second parenthesis, when n equal 1, and then when n equal 1 is 1, so there is only one term as well. So I get 1 times 1, so equal 1. We want to check whether this is this one is greater than or equal n square when n is 1. So when we get 1, we can write it's greater than or equal 1 square. In fact, 1 cannot be greater than 1, but it's actually is equal exactly 1. So it is true for n equal 1. There is no need for us to take n equal to, assuming that it is true for n equal particular k, meaning that so n equal k, you get 1 plus 1 over 2 plus dot dot plus 1 over k time 1 plus 2 plus dot dot plus k greater than or equal k squared. So by mathematical induction, we know that when we assume that it is true up to n equal k, we got this as the hypothesis. What is this given, and then we will prove that it is true for n equal k plus 1. If we succeed proving this is true up to n equal k plus 1, and then we can safely conclude that this inequality will hold for all n. Okay, so our next mission is to prove that it is true up to n equal k plus 1, meaning that we got the first parenthesis is 1 plus 1 over 2, 1 plus 1 over 3, dot dot dot, plus 1 over k, and there is one more term for us to show, because now we want it to be true for n equal k plus 1, so we don't stop right here. We don't stop right 1 over k, but add one more term is 1 over k plus 1. Okay, and then the second parenthesis is 1 plus 2 plus 3 plus dot 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 plus k, but we don't stop right here because we want to show it's true up to n equal k plus 1, so we stop at k plus 1. Okay, and then greater than or equal not k square, becomes k plus 1 together square. So this is a big challenge for us to show this. Okay, so we have, I take these two parentheses timing together, and then I am going to try to show that it's greater than or equal 1 k plus 1 over square. 1 plus 1 over 2 plus 1 over 3 plus dot 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 plus 1 over k plus 1 over k plus 1 time 1 plus 2 plus 3 plus dot 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 plus k plus 1. Okay, and then I calculate the sum by using arithmetic sequence sum for the first n the first k term. I keep this as the same. And then this one, summing the arithmetic sequence for the first term, first k term. So we got number of term divided by 2 and first term plus last term. Okay, and then plus k plus 1 like this. Next, I time this into the next parenthesis. So I got 1 plus 1 over 2 plus 1 over 3 plus 1 over k time this. I got k over 2 times k plus 1, and I time this expression by this. I got plus k plus 1 times 1 plus 1 over 2 plus dot 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 plus 1 over k, and then we time this one into this expression and into this expression. So 1 over k plus 1 times k over 2 times k plus 1, so this k plus 1 and k plus 1 simplify, leaving only k over 2. How about to the next term, because it's k over 1 and this is a k over 1, so this simplify out, it cancel out, so leaving only 1. Okay, and next, we try to observe this. This one, 1 plus 1 over 2 plus 1 over 3 up to 1 over k, and then this is k over 2 k plus 1. I think this expression and this expression is exactly the same. Do you think that? 1 plus 1 over 2 1 over 3 1 over k, this one, and then k over 2 times k plus 1 is this one. This is the summation of this arithmetic sequence for the first k term, 1 plus up to k. So number of term, because this is k term, so k over 2, and the first term plus the last term 1 plus k. I think this is exactly the same. Okay, so because 1 plus 1 over 2 plus 1 over 3 plus 1 over k times k over 2 k plus 1 greater than or equal k square. As I told you earlier, when we assume that this is this inequality holds, we are going to take it as a hypothesis for the next proving. Okay, for the next proof. So now I use this one. Next, observing this, k plus 1 times 1 plus 1 over 2 plus dot 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 plus 1 over k is greater than, if I write like this, how do you think? Can you understand from this? When we time this parenthesis, this first expression is only two term in the next parenthesis, it, you know, it's smaller. It's smaller compared to the first parenthesis time every term of the second parenthesis. But in here, I decide to time only the first parenthesis to the first two term of the summation in the next parenthesis. So I got k plus 1 times 1 plus 1 over 2. So it must be smaller than if I time for every single term in the next parenthesis. Okay, so we got what? We got this one is bigger than k squared, and this one is bigger than 1 plus half times k plus 1. So when I substitute this into this, it must be smaller than the earlier expression. And that earlier expression is what is the multiplication between these parentheses to this parentheses. So I don't want to write them again because it's too long. I would like to represent it by a. So I got a, okay, and then I substitute k into this. So a must be bigger than, because this expression is bigger than k squared. So is greater than or equal k squared. And this expression, I don't keep it as exactly the same. I would like to change it into 1 plus half times k plus 1, okay, and then plus k over 2 plus 1. Calculating this, we got k squared plus this is 3 over 2, right? K plus 3 over 2 plus k over 2 plus 1. Okay, further calculating, 3 plus 1 is 4, 4 divided by 2 equal 2, so plus 2k plus 1 plus 3 over 2. K square plus 2k plus 1 is k plus 1 together square. Plus 3 over 2. So look at this. A plus 1 and A. How do we decide which one is bigger? Because S is positive, and then A plus 1 must be greater than A plus 1. So A plus 3 over 2 and A, which one is bigger? A plus 3 over 2 is bigger because S is positive. And then this expression, I would like to write it as, if I eliminate the 3 over 2, and then it must be bigger. I mean, this expression must be bigger than 1 plus 2 k plus 1 together square. So S is what? S is the multiplication between this expression and this expression. So finally we got, it is true for n equal k plus 1. We can safely conclude that 1 plus 1 over 2 plus 1 over 3 plus dot 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 plus 1 over k time 1 plus 2 plus 3 plus dot 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 plus k greater than or equal n square safely. Okay, so I would like to hear if there is some error for this proof, and thank you for watching.